here? It's this one.
Did we learn this before?
Yeah, we did. This is why you should do your homework. Now,
Wrong.
what? You have this?
Wrong.
Ben, it doesn't matter because it's on the screen. It's no big deal. Right. So this question here is 4 marks. So my idea is I'll give you 4 minutes, then I'll give you the answer. Ready? Okay. 4 minutes begin now. You can use your notes if you need to. Go. Go.
It's the one that I missed.
I'll tell you, I don't know if you missed it. Maybe you did, I don't know. It was the lesson, I think, on page 109. Yeah. What happened? You missed it. Now you see. And did you get the notes? No.
I have something here.
Twenty seconds. Ten seconds.
Oh.
No. 5, 4. Okay, let's have a look now. Go. Look closely. So, what you have first is you have light that goes into glass. So this is air, this is glass, and you have the light which goes in from air to glass. And you're told that the N for the glass is 1.43. So here, the light has a speed of c, which is about 3 times 10 to the 8. And here it has a speed of v, which we don't know. But we have the formula N equals c over v. So you have 1.43 equals 3 times 10 to the 8 over v. So v is 3 times 10 to the 8 over 1.43. What's that, please?
Oh, 209790202.
2.17? That will do, Ben. That's fine. Okay? Yeah, it's fine. Right, now what's the angle of refraction of... Yeah?
Is that the final answer?
Yeah. Angle of refraction. So now what happens next? The light comes in at 20. And we want this angle here, which we call OR. And here the N is for air is 1. And here for glass, we said, we said 1.43. So you have Snell's law that says sine OR over sine 20 is 1 over 1.43. Yeah?
Mm.
So what's the OR here, Ben? Did you work it out?
No.
Allow me. So
Which is N1?
this one.
Uh,
Oh yeah, so sorry. I wrote it upside no. Oh, you're in radian. Okay, sorry. I wrote it upside down. It's the same thing though. So sine 20 over sine or equals 1.43 over 1. It's the same.
Oh.
Yeah. Oh, you're in radian mode, Ben.
Oh yeah.
13.8 degrees. Okay? Yeah? And lastly, what is the critical angle? The critical angle. So the critical angle is when you have the air here, the glass here, and the light goes like this. And this is called the critical angle. And the formula is quite simple. It's sine inverse 1 over 1.43. That's all.
Oh, I get the opposite.
Oh no, no
Opposite
answer.
is no answer.
Yeah, exactly. 44.4.
So I set out the radian.
44.4.
Okay.
Okay, go. What you doing? Yeah. Right, let's look at the next question. B4. Okay, so we'll do it bit by bit. So let's do the first part here. For 3 marks, just 3 minutes, first part. Go. A ripple tank just means a tank of water, and the water is moving in the tank.
Mm.
English, Ben?
No. Two ways.
Mm-hmm. One minute left. Five, four, three, two, one. So, what's the first answer? What do you think?
A
8. Good. Because the 5 and the 3 can meet to make an 8. Good. The second answer?
two.
Good. Because the 5 and the 3 can meet to make 2. Good. And lastly, the name of this process? Mhm.
Superposition states.
You use the...
Constructive interference.
Not superposition states, just superposition.
Oh,
Where did you get this word superposition states?
definition of interference.
Read it.
Yeah, like is when two or more waves combine to form a new wave, and the principle of superposition states.
Ah! That state is a verb, not a noun. So it's like saying the superposition says. So, okay, so it's just superposition. Superposition. Is that okay? Yep. But you're right, Ben. The first one is constructive interference, and the second one is called destructive. And they want the name for both. And the name for both is superposition.
Pardon.
So constructive and destructive interference, the name for both is superposition.
Okay.
For both. Okay. So now look, if you look at the next part, what happens is you have two waves coming out from X and Y, and the distance here is 15 centimeters, and this distance is 80. And the waves come out, you know what's happening. First question, what is meant by coherent? Second question, sketch what you see here. Third question is explain what you got here. And fourth question is what's the wavelength? Alright, so this one is a bit hard. And then 1 mark, what would happen if you reduce the wavelength? Okay, this is a hard one.
So where is 15 centimeter?
Between X and Y. Right. Okay. How many marks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 minutes. You can use your notes. Oh, sorry, 12 minutes, is it? 12 minutes, okay. Yeah.
You don't have something in the middle with the.
That's right, Gail. So what's happening is you have a wave coming from X and a wave coming from Y. Yeah, well, the fringe width is the x in the formula.
Oh, okay.
Which do you want, the fringe width or the fringe pattern?
The waistline. The waistline.
This part?
No, for terminal waistline is way too.
Yeah. So you need to use the formula with the x in it, the fringe width, yeah. How are we doing? Are you finished? You think you're finished, Gail? Ben? Will we look at the answer? Okay, so let's look at the first one. So what is meant by coherent? Did you get the definition, coherent? What is it?
Have a constant phase difference and the same wavelength.
Good. Now, maximum and minimums are observed along the line. Sketch the amplitude. Now, I think I saw, Ben, you had a sketch, didn't you? Can I see for part 2? Yeah, that's fine. That's fine. The only problem, small problem, is this one is more than this one. So you should make this one bigger.
Okay.
And then look, smaller, smaller, smaller. The one in the middle should be the biggest circle. Did you sketch?
Do you want this?
Well, Ben was being extra good. They wanted this.
I thought they want this kind of.
Well, here, I'll draw. Well, okay, they want this. So, here it is here. Okay, so what happens is, like Ben was drawing there, the waves come in. Okay, this one here will be the biggest wave. And then here, smaller, and then here, smaller, and then here, smaller, and then here, smaller. Okay? But if you were to look, there's my eye. If you were to look here, what you would see is that this wave was the biggest. And then they have another wave here, not so big, and another one here. That's what you would see. You know, if you picture, like this is water, okay, and this is a wall, but let's say it's a glass wall, and you were looking at the glass wall, you would see the wave that hits the wall here is the biggest wave. So it has the biggest amplitude, and then smaller and smaller. So this is what they want. So you were close, Ben. Where's your picture? So just maybe draw like big wave, smaller, smaller. Okay? Is that okay? Is that okay? Right, next. Why do you have maximum and minimum? Well, what happens is, here you have a maximum. And the reason you have a maximum is when the two waves meet, they add to make a bigger wave. And this must be because the path difference is 0 wavelength. So what happened is you had a peak, and the two crests, they meet to make a bigger crest. So you can say that at a maximum, the path difference is 0 wavelengths, and so a crest meets a crest, and that makes a larger wave. Okay? Now wait, before you write that down, tell me what happens at a minimum. So, minimum, the path difference equals what? What do you think at a minimum is the difference between the two paths? No, because that would be the same as 0 lambda. You know, if you have two waves and you move one of them one wavelength, it's really the same.
2. Half.
A half. A half.
Which half is crest?
Yeah, correct. So a crest meets a trough, and this makes a smaller wave. Is that okay? So 2 marks and 2 marks. Okay, do you need to write this down? What did you write? Yes, but the only problem is, Ben, is they did say in the question you have to talk about path difference as well. Yeah. So nearly. Ow! Oh, that was sore. Okay?
Oh, another thing, could you write a sigma?
Sigma?
I just forgot.
Which small or big sigma?
Both.
Small, big.
Ah. Okay.
Right, next. Right, so they want to know what's the wavelength, and the fringe width is 10 centimeters. So basically they just want you to use the formula, you know the one, x equals lambda d over d. So lambda is x d over d, which is 0.1 times, no, what was it, 0.1? Yeah, times 0.8, no, 0.15, wasn't it? Yeah, over 0.8.
Oh, yes.
And what was that? Let's calculate.
I got 1.87.
What?
Yeah,
No.
1.87 times
Oh, okay.
times
Sorry, 1.87 times 10 to the minus
minus 2.
2 meters. Ooh, I'm hungry. Right. Yeah, so that's 1.87 millimeters, yeah?
Yes.
Yeah, okay. Lastly, for this part,
Oh, you see,
thank you, Ben. CM, not MM. What would happen to the fringe width if the wavelength was made 4 times smaller? So what happens to x if the wavelength is 4 times smaller? What happened to x? Bigger or smaller?
Smaller.
Yeah. X would also be 4 times smaller.
What?
Only 1 mark. Now, we'll finish. We still have this to do, but we can do that some other time, okay? Please, please, please go. You need to get the notes for what you missed, and you need to do your homework. You too, Ben. And you too, Khalifa. I was waiting for you yesterday for your book. Right. Let's go home and rest and sleep and eat.
Oh, eat.
Good idea. Right.